do your project. What is missing? Yeah, Austin? Sorry, threads? Yeah, threads you need to learn. Anything else? You think you can write object-oriented programs now? On your own? I've been helping you guys, right? I've been telling you, go and do this object. Have a little setter here. No, and it's all sort of, has come together. And the general problem is, how do you break up your program into multiple classes? Okay, and like I said, I've been leading you on. Okay, and it all seems to fit together right now, and there may be little glitches here, and you might have done things a little differently and better. But tomorrow you have to teach this course. You have to go and come up with the objects. Can you do it? Okay, so that's a general problem. And I've said this many times, and I'll say it again. This is an extremely hard problem. Okay, and it would be nice if what you learn from this course you could apply to other situations. Right? You've done this big project, and you've done the simulation, but hopefully what you've learned here goes beyond the simulation. Of course, the interfaces, threads, objects, classes, they definitely go beyond. That's Java. Okay, but there is something about how we use Java in this particular project. And it'll be nice if some of that translates to other situations too. Okay? It'll be nice if you learn some patterns on how to use Java, not the constructs in Java. I mean, that any book will tell you. Okay? Not any book, but lots of, if you Google, you'll learn any Java construct. It'll be easy to learn that, okay, in some book. But how to go and use these constructs in a useful way, okay? And do you guys remember this principle, separation of concerns, as a way to decompose, as a principle to use when decomposing your program? I went through it very briefly. In fact, we lost a recording for this, but somebody was paying real attention. Do you remember what that was? Or what that? Okay, so if you don't remember, how could separation of concerns, the English phrase, somehow be a guide to how to decompose a program into classes? Austin? If you have, so you start off, with a monolithic program, let's say, or a monolithic class, and then you say, you know what, this part and this part are independent. And if they're independent, maybe they should go in different classes. KJ?
Create classes that have, I guess, like you say, independent responsibilities, so they do separate things, so they make their own class. If one kind of relates to the other, compare it or extend it.
Okay, so then of course you could, then you could inherit or extend and say, look, the inherited class could exist independently of the inheriting class. So let's go and make them two different classes, right? But what's the litmus test for knowing whether two things are independent? I mean, I could say that every statement that we're going to execute in a list of statements is independent, but that's not quite true. So, if somebody doesn't like to break up their program into classes, and they will say, give me some objective criteria to decide that this is independent of that, what might that objective criteria be? Zach?
If one of them didn't exist, it wouldn't affect the other.
If one didn't exist, the other could still exist?
Yeah.
That's a strong definition. That's a little stronger than what we need, but that's pretty good. Okay, that they could exist independently. It's a little stronger than what I want.
One should only do what one does best, and let the others do what they do best.
One should only do what one does best, and the other one do what it does best, right? Best, there's a little subjectivity there, and we can't get rid of subjectivity entirely. Okay, but that's kind of saying they work independently, and independently they'll do the job, and maybe dependent together they may not. But if there is a program, I give you a program and I say, based on this, what you have to do, or this collection of programs you're going to build, I can argue that this is independent of the other. We kind of saw this before in an example. We said, look, maybe my history without the display is not very useful. Maybe it can't exist. Okay? It's just not a very useful thing. It can exist, obviously, if you can create a separate class, but it's not practical to have it without that. And we said the same history could have a different display. Okay? So I'm kind of arguing that these two things there has to be some display of history, otherwise history is boring. Okay? But the point is the same history could be displayed in the same different ways. Okay? Then the semantics of history, collecting items together, providing access to read methods and write methods, is independent of how you display it. And you can change display. You can change the display without changing the semantics. That's the basic point, separation of concerns. Okay? And so they should go in different classes. Okay? Because otherwise you'd have to go and take this piece of code, copy and paste, edit it, and then when you go and change semantics one place, you've got to change the semantics another place. So that's not a very good thing to do. Okay? So that's why we said maybe the display method should not be in history, it should be outside, even though it sort of goes together. Okay? And in general, if you have some class, some piece of code that has functionality A and B, okay? And if A can change, if B can change without changing A, that means B can become B prime, then A and B should be in different classes. Okay, that's a general rule, and people will tell you that again and again and again, and you'll say, yes, it makes sense. But when it comes to programming, you won't know how to find the A's and B's and how to separate them out. You won't, meaning we're all mortals, and it's very difficult to do so. So this is the general principle, but we need more than this principle. We need some formula. Okay? You are in this situation, this is the formula you use, and you can go and decompose your program into multiple classes. Okay? And we need some patterns. Okay? And, a pattern is some recurring theme. So we want to know that this particular theme has occurred again and again, and occurs again and again, and we go and say, okay, I've got to create this particular compiler, and in the Holy Grail project, I had this pattern that I learned, and this pattern applies also to the compiler, so guess what? I'll apply the pattern here without thinking much. Okay? And the word pattern, of course, is very general. So we saw that when we go and name our methods, and provide types for that, within a particular class, we use certain patterns to go and organize our methods within a particular class. Okay? This is not talking about multiple classes. Okay? Then, when I teach 110, we say, okay, there's loops and loops and loops. And we would go and say, okay, there are these event control loops where you can't know at the beginning of the loop how many times you'll go through it. So some event occurs that decides when you will terminate. And then there's counter control where there is a counter and we know how many times it'll go through or the maximum number of times it'll go through. So we see patterns like that. And then, I teach you a pattern in class. I emphasize the pattern in recitation, and then you use the pattern in your assignment. Okay, that's the basic thing you guys do in classes in general. Okay, so we see that there is patterns to organize our methods, pattern for loops, and we'll go and look at something called design patterns now. Okay, if you Google on design patterns, you'll get a lot of hits. This is the essence of object-oriented programming. If you know design patterns, you know programming. Okay, and it helps identify the kinds of classes a program should have. Okay? And there is the Bible of this subject, okay? Design patterns. This is a guy called Ralph Johnson, who was a professor at Illinois. He and his students wrote this book, and it's basically a reusable pattern for decomposing a program. Okay? It's many design patterns. Okay? So this is a collection of design patterns in this book. And when we say reusable, we typically talk of a reusable method, a reusable class, a reusable interface. No, we're not talking at that level now. It's not a piece of code. It's an idea. Okay, so it's much tougher. It usually, you can have infinite number of interfaces and classes that follow the pattern. Okay? And that's why this is good. That's why it means despite, that you can go beyond the classes and interfaces you learned in this class to another project and learn and apply those concepts. Say, oh yeah, I had this pattern there, I'm going to apply the same pattern there. And for instance, undo has a pattern associated with it, and you're going to say, oh, I need to do undo in another application, I'll just use that pattern. Literally, it'll be so simple once you see the pattern. Okay? So, the things we saw earlier, like inheritance and interfaces, they were hard to explain. They were hard. I mean, they were conceptually hard. Okay, and these ones, once you see them, they're easy. It's like almost boring, but very hard to identify on your own. So these are one of those things. And so the next pattern we'll see, the next assignment is going to be relatively easy because once you understand the formula, it's very easy to apply it. Okay, they're language independent. So this is not Java based. It will apply to C++, Python, wherever, whatever. And the purists in this system, and Ralph Johnson is one of them. They distinguish between patterns, architectures, and frameworks. And we're just going to talk about all of these three things as patterns. Okay. So what I'm calling MVC and what we're saying MVC is something actually that is not strictly a pattern but a framework. But it's the definition I'm giving you here applies is more broad. Okay. You can take some software engineering course to learn the subtleties between the subtle differences between them. Okay. And this idea was actually inspired by I got his name spelled wrong here, by an idea in another field, architecture. And Christopher Plummer had this notion of saying that, look, when we have buildings, there are patterns, and you guys are probably seeing them much better than I can. I guess I went very quickly through that. And even when you don't have cookie cutter houses, where this house is a replica of that house, even when they're different, there's still some patterns that they're following. Okay, and the idea, and he came up with a list of architectural patterns. And from what I know about that subject, the idea failed there, but it was the inspiration behind design patterns. So a sort of failed idea led to a successful idea in another field. So maybe it didn't fail actually. Okay, so MVC motivation actually comes from the example we saw. It's an extension of the example we saw. We saw that there's semantics and there's display. And we'll go beyond display and we'll talk about the complete user interface. Okay? So we're going to say not history, but just some object with some service, not the history service, but some semantics, some service, and some user interface, not just output like display, but also input. Okay? And how can we go and separate the semantics and the user interface? Okay? And that's the question that MVC, which I'm calling a design pattern, will solve. Now, does that seem like a practical thing to look at? Separating the semantics of an object from its user interface? And I mean, the answer is yes. So in what ways is it practical? Why would that be a good thing to do? Firstly, if we can figure out a pattern here, that pattern will apply to any interactive application. So there's lots of interactive applications. Okay? So this is a good pattern to have because anytime you have an interactive pattern, you've got a formula.
It's also good for debugging in that, if it breaks down as displaying, you have to separate, then you can test where it actually creates or not, and if it displays it, instead of having to debug both.
Excellent. I didn't think of that idea, I didn't think of that reason actually here. But you've got, when you have separation of concerns, in general, you can debug each concern separately, and so that's always an advantage. Okay? So even if I don't have this litmus test and saying, oh, do you really have another program that reuses this component? You say, I don't care, I can debug. Okay? Having said that, let me tell you, sometimes when you break up your program into so many objects, each object you can debug, but debugging their collection and the interaction is a real headache, and you're going to face that. Okay? And you can comment each little object and understand it properly, but commenting their whole flow gets to be a pain. So, in fact, I'm teaching also a course on distributed systems, and I had broken up something into 5 different classes, and I knew in their project they won't have to do it. So yesterday I was doing reverse inheritance. I was taking all the things that inherited and combining that into one class so that they could just see it all at one place and understand it. Otherwise, it'll be distributed elsewhere. Okay, so, there's this danger. Okay, But other reasons? Okay, so this is from a programming point of view. What about, so there's the programmer's point of view and there's the user's point of view also. And generally things have become popular not when they made the life of the programmer easy, but when they created some new feature in the user interface that could be apparent to the end users, and people said, if I follow this software engineering principle, I can create a product with features that I couldn't create before. That is typically the more compelling reason for strides in software engineering occurring. Okay? So think of both reasons. Can we build new kinds of applications that we couldn't build if we did not do the separation? And also, can we make our life easier? So, other reasons? So Zach?
As far as the user goes, it would probably allow for easier customizable user interfaces.
Okay. So it'll allow us customization. You could go and just flip one user interface to another interface.
Yeah, modularization is what I was going to say.
So the modularization at the program level allows customization at the user level. Because you just say, I want to do this one. The same program is running. You don't have to go and run a different program, and it changes the user interface.
So, the UI perspective, or the medium communication of the object semantics, so different people could desire different types of perspectives.
So not only could you customize, you could have one UI for one user, another UI for another user. That's your argument, and Zach's argument is even for the same UI, for the same user, you could change the UI. Today I feel like seeing this display, and tomorrow I feel like seeing this display, perhaps. Okay? Other reasons? If you're separating them and putting them in one program, could you imagine, and I teach distributed programs, so you can imagine, I'm thinking along these lines, could I just separate them on two different machines also? If they're not separable logically, then I can't separate them physically also. So can you imagine having the program run, semantics run on one place and the UI run on another place? Is that something we see a lot of? Anytime you access a web service, where is the UI created? On your own computer, the browser. And where is the semantics running? Some server. And then if you have one UI, and then you can have the same service perhaps with multiple UIs at the same time. Okay, so I could be accessing the object, and you could be accessing the object at the same time. Or I could be accessing the object using multiple UIs. Okay, so this is actually an extremely useful concept. And historically, let me tell you that the Smalltalk guys invented this idea, and they were supposed to write a book on it, and they didn't. And then this guy, Ralph Johnson, he was at Illinois, and he was just studying their code, and he found this pattern, and then they wrote a paper also, and he also found this pattern. And nobody cared about it till this world of collaboration came around, and people said, we need to have multiple people access an object at the same time. How should we do it? And then, some of us who knew about the model view controller went and said, that's a solution. Okay? So just do this in slow motion now. So if we could separate the semantics from the UI, then we are able to answer several questions. Okay? And those questions are, A, how to debug things separately, how to reuse code among different interactive applications, which is the customization part, that I want to write one program and have different users have different UIs for it, and we don't want to re-implement the semantics each time. We want to just re-implement the user interface, okay, and have different implementation, okay? How to simultaneously create multiple user interfaces for the same service. Okay, so I've got some data, and I want to see it at the same time using either a pie chart or a bar chart. That was the classic example Smalltalk came up with, actually. Okay, so just one user getting different views of the same object. Okay, and we see that today. I mean, look at this. My PowerPoint, I can have the normal view where I have a little outline here and I have the main slide here, or I could go to the slide sorter view. Same data being displayed in two different UIs. Okay, this is the example that I can customize. I can configure one to the other. Okay, we see that here. Then this is the collaboration world that came around and said how to simultaneously create multiple user interfaces for the same service on different computers. Okay, and you can imagine, and we see that today. Okay, you can create your Facebook UI on your smartphone. You can create it on your desktop. 2 different UIs, same service. Okay, so this whole idea made it much more practical. Okay. And you can also imagine, you guys, many of you have probably used, how many of you use Google Docs? A lot of you. Okay. So, different UIs on different computers. So this is the example where the doc is at Google and you guys are all creating different UIs. Your browsers are creating different UIs. And is that the only, and so that, that's good. We can all be editing and sharing this particular object. Is there some other way you could also do it that doesn't involve creating multiple displays? So right now, we guys are sharing this stuff also, sharing a display also. So what does Google Docs give you that we are not getting right now? A cursor. Okay? And of course, we are all in one room. And you guys have to have pretty good eyes in the back to be able to see things. Okay? So what this gives you is distribution plus a cursor input. And can you imagine having one display and multiple cursors? Does that look like a practical idea? Sorry? Google Docs gives you different displays. Each one has got a different display. Okay, I'm talking about one display with multiple cursors. Okay? Supposing we could do something like this, that each of your mobile computers could go and control the presentation, and we could be, for instance, doing PowerPoint editing of a slide to write a program, and you guys could edit it, and I could edit it, and we all see one display. Okay? And this is not entirely hypothetical. Before PowerPoint put recordings into the program itself, I used to record this using something called Live Meeting, which is a Microsoft product also. And I would go and do something like Google Docs, where every computer had its own display, and I would go and broadcast that using Live Meeting. And Live Meeting also recorded things. That's why I was doing it. And there were times when I would type something, and as I was typing, somebody else was correcting it as I typed. So that was pretty cool. Okay? So there's a lot of things we can achieve if we could somehow figure out how to separate the semantics from the UI. Okay? So how do we do it? Okay? We're going to build the program, we're going to build the UI, so we're going to have lots of code. So since we're doing so many different things, let me keep my example as small as possible. So so this is my example. Okay? It's a trivial example compared to what you've programmed, but it illustrates the points. So we're going to have a counter. Okay? That's all. Our service is a counter. And what does the service let you do? You can add arbitrary positive and negative values to an integer. Okay? And you can display the integer. So you can read the value and you can write the value. Okay? And we'll show that even this particular simple object can have multiple user interfaces. You can imagine more complex objects will have even more variety in user interfaces. Okay? So here's the UI that I could write easily using Java. Okay? That you guys could all write. It's very simple. The program comes up, it tells me the counter is currently 0. And I type 1, and it says, okay, I have incremented the counter by the value you entered. So the counter is now 1. Then I say -1. It says, okay, the counter is now 0. 5, counter 5. Okay? Not a complex application, okay, by itself. And here's another UI. Now I am not using the console window to display the value. I use the console window only to input. Okay? And whenever I input, the new value is displayed in this little separate window here. Okay? So the counter value is being input in the same way, but the output is changed. Okay? So another UI. Okay? Not quite as complex as the PowerPoint UI, but it has the essentials. And I go and enter -1 now, and it says the counter is 0. Okay, so I see in the console only my inputs. I don't see the outputs. The outputs come in this alert window, message window. Okay? If you know how to display message windows, which is very easy, this is also by itself not hard to implement. It's going to be challenging is to reuse the code. Okay? And of course, you can imagine that you want both UI. So I gave you the example of the bar chart and the pie chart. Okay, my analog here is that I see the output also in the console window and also in this alert window. Okay, so I've got two UI, two displays, and only one way to input. Okay, so I'm always entering in the console window and displaying things. Okay, so that's my UI. That's my program. I want to go and somehow write code that does these three applications right. Okay, questions? So how do I implement? Let's go and start off small. Let's go and implement this UI. Okay, and you guys can do this in your sleep. So and if I don't put any constraints on you regarding modularity, okay, and we go and say, okay, we've got a main class with a main method, and I initialize the counter to 0, and I go through a loop which I terminate when I get 0. Okay, if the guy goes and says increment by 0, I'm saying the guy, probably wants to end the interaction. And otherwise, I just go and add to the counter the value. And after each add, I go and print the value of the counter. Okay, this is all 110 stuff, and this you can do, right? So this is my program for this console UI. Any questions about this? And if I want to go to the message thing, all I do is change. I go and change my print line by some other statement that's conceptually as the same. Okay, rather than saying print line system, I say JOption pane, show message dialog, and where I gave us, I have to put this funny argument here, which I've forgotten what this is about. And the real argument is this particular string here. So where I passed a string to a print line, I pass a string to some other routine. Conceptually, it's the same thing. Okay? This is not part of the language, so I have to go and import this JOption pane. Okay? So I went and wrote this program. It changed, one line changed. Okay? And you guys, by the way, are free to use this stuff if you want to use this. Okay? Questions? I want my mixed UI. Okay, so we've got code duplication, and we've got to figure out how to go and change, get rid of this. And let's just hold off that. My multiple UIs, okay. So where I want to go and show both UIs, I go and okay, I'm not quite sure. So I guess I've forgotten what flow I have in my slides right now. I don't want to give you away the solution in the next slide. So let me just say that we basically, you want both UIs, you just go and put both the show dialog and the print line, right? So that's fine. So let's try to answer the question now. How could I share code now? Okay, so I guess what my flow was, now I remember what my flow was meant to be. My previous slide showed that I had duplication of code. And this slide is trying to show you that I can't simultaneously create two UIs to the same code unless I put the two print lines there. So let's go and just solve the first problem. How could I share code between the console UI and the mixed UI, where there's a console for input and the GUI for output? Use inheritance. So I would have, how would I use inheritance? I would have one class that does what?
So mixed UI is using stuff. You could have mixed UI
So the mixed UI could inherit from console UI. Excellent. Okay, and it could just go and override this some writing method and add a piece of code that does that. That does the graphic GUI thing, right? And can you see a problem with that though? Yeah.
A separate UI, which is just the other part.
You can't create a separate UI which is just the GUI part, right? Zach? Also with inheritance, I can't simultaneously have both UIs. Okay, so supposing I want the mixed UI and I want the console UI at the same time with the same counter. I can't quite get that. Because when I go and inherit, I go and duplicate the code. So I'm basically, I've got one program that is using one counter, another program that's using another counter. The counter value is not being shared. Yeah. You can use protected methods, but you can't have the same counter value. See, you can't. I guess it's the same thing that we said earlier, that if you can't have, you can't have the other UI. Supposing, forget this thing. This is not the best illustration. The pie chart and the bar chart. Okay. Firstly, should the pie chart inherit from bar chart or bar chart inherit from pie chart? Okay, we get into that issue. Even if we decide that pie chart is going to be the main UI, and then bar chart is going to be the auxiliary UI, and we'll go and forget about the ISA rules and make the pie chart inherit from bar chart. I've got one class that is the bar chart. I've got one class that is the pie chart. If I run them simultaneously, they both have separate copies of the counter. I cannot have one counter value being displayed simultaneously by bar chart and pie chart. Zach?
You said a method to just initialize the counter and not have it, the charts extend the counter, and so then you just feed it the same counter.
Okay, so somehow we go and feed the bar chart and the pie chart the same counter. That is what we need. We can't quite do inheritance for all the reasons you guys mentioned. Okay? So how would I change my program? I would make this into, tell me concretely what I should do here. Feeding it a counter, meaning what? What is going to be my counter at this point? An int value? That's what we want to do conceptually. We want to create one UI and another UI, both of which are fed the same counter value. Yeah, Austin?
Create three classes, one of which keeps track of the counter, and then two classes that take input from an instance of that class.
Absolutely. Okay? We want to feed it a counter. We want to feed it a counter object. Okay? And that counter object would be defined by its own class, which means my UIs would be different classes. So now I'm beyond this one class. I've gone to multiple classes. Okay? And what might that class look like? What methods might that have? Get counter and increment counter. We got it. Yeah.
So it's just a bean.
It's a bean-like thing. Yeah.
So I was going to say too, share code between these two UIs, what you can do is you can put them both in one package and then make their own methods default or protected.
Yeah. So we can once we've got that object, we can now have a UI classes, and the UI classes can have both protected methods that just do things that other classes don't need, or they can have public methods. Okay, James?
Why couldn't the counter code be in a separate method as it can be in its own class?
Why can't it be in a separate method within the same class? Okay, so counter is a value, right? So you're going to make the counter value a global variable, an instance variable, or a static variable. And then I have one method to display it as a console value, and another method to display it as a GUI thing within the same class. So I'm going to keep changing that class again and again when I want different UIs. why do we break things into multiple classes so that, I as a programmer can just look at this set of methods, okay? And then what if I want one UI without the other UI? I've got all these other methods loaded into memory. Because once a class gets loaded, all of its methods get loaded. If I put them into separate classes, only the classes that need to be are loaded. So we don't have to go and all work on the same class, have a bottleneck, and I've made this change and you made this change, and how do we resolve the conflicts? So we don't want to put all of that functionality in one-to-one class. That's a separation of concerns idea.
I was just curious if it was a style thing or more, or if it was actually going to have errors.
It's a style thing, okay? Because you could put that whole thing. In fact, PowerPoint, even though I gave you the example that, it's got multiple views, I won't be surprised if it's all one big program, okay? And so it's simulating, but ideally, just because PowerPoint evolved in certain ways, okay? And so that's why we want to do separate classes. So I'm going to have my counter model, and I'm not going to have a setter there because we're not allowing the user to set a value. We're only allowing the user to increment or decrement, just the way we defined a counter. So it's counter is my class, and I've got an add method and a get value method. Okay, the add. So I've got now a separate class. Okay, and now there's no UI here. I don't have to go and worry about how it's displayed when I'm dealing with this class. Okay, so all the things we saw earlier, easy to debug, easy to understand, all of those apply here. Okay, and now things are going, and there's no input or output here. I don't have anything that has to do with processing the user, what the user typed in, or displaying to the user what they should. Okay, and what I'm going to end up doing now is creating my pattern. Okay, I'm going to say that I'm going to have a counter, okay, which is the interface here. It's going to be an object, and that is an instance of a class, of an interface called counter. And we're going to have three separate classes, a console UI, a mixed UI, and a multiple UI, all accessing the same class. And in fact, they will be able to access the same object also. Okay? And because they'll be accessing the same object, we'll be able to display the same value to multiple users, multiple computers, everything that we wanted, we'll be able to do. Okay? And so this is the model, and these are the interactors. Okay? The word interactor is, if you Google on interactor, you probably won't find many hits there. There's something called model view controller, and people often call the interactor also view, and it gets confusing. But having seen the history here, the word editor has been used for interactor also. But the word editor is used also as a standalone program. So it's a pattern that people implement a lot, but don't have a good name for. Okay, and I'm just going to call it model interactor. Okay, so this is the model, and the others are the interactors. These are the interactors or editors. Okay, questions? Okay, so my model then for this is this particular class, which we already saw. And my UIs now look like this. Okay, let's go and see. So how is this UI going to change? Where I had int counter equals 0, I would have now what? I would have some kind of counter object that I'm either passed or I create. Okay? Where I said print line counter, I would be saying print line get value. And where I said counter plus equals next input, I would say counter dot. Okay, it looks very object oriented, right? And we've got a separate object, and we are invoking the methods there. Okay, so my edit method takes the counter as an argument. Okay, I'm not instantiating it here because I want to be able to access a counter that is also being accessed by other UIs. Okay, so this object is passed to me. Okay, edit, and if you look at object editor.edit, that's the same kind of method. Object editor provides you with an edit method that takes an object as an argument, which it displays. That's what my UI interactor is doing. It takes a counter as an argument, and then we have the counter.getValue and counter.add next input. Okay? And my mixed interactor takes the same counter, and it just goes and does show message dialog rather than print line. Okay? And, okay, I'm going to back off. Yeah.
So because you've got edit there and a class above these classes, you could give all of these the same counter.
Okay. So I have my model, I have my UI, and somehow they have to be connected to each other. So there's a class above that, like you said, that connects them together. Just as I keep telling you, there's a boombox you can buy, or you can buy the components, and then you become the class that joins them together. And that class is going to be our main class now. So where my main class is doing everything, now my main class has got counter, it's got these editors, and it'll bind the same counter with multiple editors. Okay? So now I'm going to talk about. Now we saw one UI earlier and another UI now, and what was different between the two UIs? Just this line of code, right? Where I was doing print line, I'm doing show message dialog. So while I've been pretty good, I'm not being that good because this code here is repeated. So we're going to go now and try to figure out how to decompose even further and separate this code from this code. Okay? And a more high-level way of saying this is that a UI is input and output. What I've done so far is separate the I/O from the semantics. Now I want to separate the I from the O. I want to separate the input from the output. Okay? So can we just quickly go through and say which do you think would be output and which is input? So this particular show message dialog, you would consider that to be read int, input, right? What about counter.add next input? Or even next input equals 0. What about these two pieces of code? It's both input and output. So why is it? So hang on. This line you said is what?
That's input.
That's input because you're processing input, right? That's in I/O is not just receiving input; it's processing input also, whatever that means. And it seems to end the program is sort of up to the UI to do. It's not something part of the program, right? It's certainly not output. Counter.add next input is, you're saying input and output, and that's very interesting.
Yeah, it's inputting and then it's immediately being outputted in the next line of code.
Okay. So it's being input and it's being outputted here. So we already assigned this to output. So maybe this is just input then. Okay?
Does I/O mean input output?
Yeah, I/O means input output. I/O means input output either from the user, which is what we're talking about, or input output from where else could a program get input and output? Sorry? Another program. That's a very good way of looking at things. People didn't get that realization till a long time into computer science history. File, disk, network. Okay? That's all called I/O. But we're going to here we're talking of interactive I/O from the user. Okay? So, now that I have a definition of a model, we know what a model has. Okay? Actually, I haven't quite got the full definition. This particular part is doing what? It's translating these three lines of code are translating what the user input into a call on the model. Call to a write method in a model. Okay, I didn't mention read and write methods, which is what I'll do now. A model has typically read methods and write methods. Okay? And what the output did was take the model state, call read methods in the model to get the model state and visualize it. That's our view. That's going to be our output. Input is going to be taking user input, doing all the actions necessary to translate the user input into write method calls in the model. Okay? So this is all input, this is output, and that's what this is saying. And this leads us, and what we see here is that the input-output code is duplicated in the following sense, that our output changed, but our input remained the same as previously. So even though the program is not monolithic, my UI implementation is monolithic because my input and output is a program. And we see here that when you have both of these UIs, again the output changes, but my input remains the same. Okay? And the drawback of monolithic UI is that I have the same way of inputting in all three schemes. In all three schemes, I'm inputting from the console. All I'm doing differently is output. And so the input remains constant, the output changes, and I haven't used that separation in my code. Okay? So I need to go and separate that. And so this is duplicated input code, which remains constant everywhere. And in these two UIs, in the multiple UI and the mixed UI, the output code is also duplicated, right? The output code happens to be shared from the previous example. So we are going to go away from the model interactor pattern to the model view controller pattern, okay, which I've kind of led you into. So now I'm talking more formally what I said earlier, that our semantics, our model, has read methods and write methods. Okay? Those read methods may be my getters, they may be my element add methods, they might be my get counter methods. My write methods may be setters, add element, increment counter, whatever. It's up to the programmer to decide these are my read methods, these are my write methods. And the view is going to be performing output. Okay? As the name indicates, the view is the one that displays an object. And the controller is the one that performs input, which means it takes user actions and translates them into calls to write methods. Okay? So that is my MVC pattern. Okay, James? Question?
It's controller model view, but you're acting as model view controller.
Oh, because you're reading it left to right? My animations, I don't know whether they went that way or not. No, so that's just how I drew it. The model is in the middle. Okay? And just read model view controller. Maybe I didn't even think of this. Maybe my view should have been on the left then. Okay? Okay, you guys get the basic idea? KJ? Questions? Okay, this will be clearer. So view can be on computer with big screen and controller on smartphone. Okay, we've got a lot of flexibility now. Okay, or they both can be on the desktop. Okay, and in my counter case, my controller is going to be doing that. Is going to be the object that goes and processes console input. That's all it's going to do. My view is the one that's going to be either displaying this particular dialog, this particular message box or not. Okay, so you want to change to console view, we keep the same model, same controller, just change the view. I mean, that's what we want, right? That's what we want from a pluggable system. That I want to change my speakers, I just change my speakers, nothing else. Okay? And I can have multiple views that are connected to the same model. I want the multiple view thing. I go and have a mixed view. I go and create a view for this and a view for this. Okay? So then we have to go and answer the following question. And that has to do with the issue that was raised earlier. That when the user goes and inputs something, we want the output to display, the view to change, right? So I have isolated things. I've said the controller is the one that goes and calls the write method. The view is the one that goes and calls a read method to display the object. But after I have entered the value 1, I want the view to change, right? When I was all doing it in one loop, that was very easy. I changed the value and then I go and change the output. Okay, and there was only one view there. Now I am a controller that goes and takes the input, and there are lots of other views that have to change, and they are not in my class. Okay? So how do we trigger a view update when a controller invokes a write method on a model? So the user has input something. We want the view to change. How do we make refresh happen without the user going and saying refresh? How does the view know that it should call the read method to display things? Zach?
Can it tell that the model was changed?
Can what tell? The view? So you're saying the model goes in. It can't tell on its own unless it keeps polling. So it would need to get what? A notification somehow from the model. That's one way to do it. That the controller tells the model tells the view. So do we want only the corresponding view of the controller to change or all the views to change? What do you think? All? And what about when you say corresponding? There might not be a corresponding view. There might be one controller with multiple views. That's what happens in our application. That both the mixed UI, both the console view changes and the GUI changes. Okay? So this is pretty indirect, right? The controller tells the model tells the view. What's a more direct way? The controller tells the views. So now, which do you think is better? Zach's method or... So what's your name?
Jeremy.
Jeremy? Or Jeremy's method?
The only problem I can see with the controller telling the views is how does the controller know how many and what are all the views?
Okay, how does the controller know about what are the views and how many they are? We are binding them together. Whereas with your method, there is a model, and the model is the repository for all of this stuff. Okay? So I'm going to tell you guys something now. How many of you have heard of model view controller before you came to this class? Okay. Model view controller is one of these overused and somewhat abused term. I mean, people use it all in different ways. Okay? And if you've learned model view controller under the web term, in a web course, they mean something different. Okay? And in the web world, the model happens to be in the server, and the view and the controller happen to be in your browser. And in the web world, a server, at least before Ajax came around, the regular HTTP protocol, the model cannot push things to a view, cannot go and contact a view on its own. Okay, it always goes and retrieves value. You can only retrieve values from it. So it can't just call methods in a view. So in the web world, the method I propose and at what Jeremy mentioned is the one that's used, by the way. Okay, that's not what we'll call model view controller. We'll assume that the model can push things into the view, but under certain technology you can't do that, in which case you do the second best thing and have the view contact the controller. And there is the controller there, that's the controller in your browser. It can't contact controllers in other browsers, and that's the way things are. And so that's just, I just want to tell you that when you learn of MVC in other courses, it's not quite the MVC you learned here. Okay, this is the pure MVC, assuming no constraints. Okay, so we are going to have, by the way, your controllers, different controllers, you can have a menu be one controller, your buttons be another controller, your shortcuts be another controller. All of them are isolated from each other, and they're all updating the same view. So there can be multiple controllers per view. There can be multiple views per controller. This world is very, very flexible. Okay? So syncing controllers in view. Controllers could go and tell all the views, and which in the web world you have to do. But a controller tells one view in the web world. But if you have multiple views and if you have no constraints, what you instead do is use what is called the observer pattern, which is a sub-pattern of MVC, where when we said that the model notifies the views, the notion of notifying another object implies that there's one object that is being observed, which is the notifying object, and another object that is getting the notification, which is the observing object. So changed model notifies views, the views are observers, and the model is the observable. Okay? So we've really learned two different patterns here. The bigger pattern, which is the MVC pattern, where the model notifies the views. And it is not only a model that can notify views. In general, an observable object, which may be a model, may not be a model, you'll see that in later lectures, notifies its observers. Okay? And we are going to assume the observer pattern in our MVC definition. Okay? And you can have multiple observers and observables. So you can have one observable with multiple observers. And you can also have the same observer observe multiple observables. And in our world, that means a single view displaying values from different models. Does that make sense to you guys? We saw that one model can be displayed in multiple ways: pie chart, bar chart, GUI, console view. Can you imagine multiple models being displayed by one view in some practical application? You can have multiple windows, but each of them will be a separate view. Have you ever done things where one view shows multiple objects? Which could be, you could imagine as multiple models, Austin? Text and image. Okay. You know, some kind of game, this is not my example, but this is some kind of game showing, you know, each tank and each plane you would imagine to be a separate model, separate object, independent, and one view that is sort of showing them all together. Okay. Your project has so many models being displayed in one window, right? And so how does observable know about its observers? So that's the next question. And there is some registration method. Okay, if you guys all want to get notifications about when I change a web page, okay, you will somehow register with me, or maybe you'll enroll in a course, and I know about you. So we need to have each observer registered with an observable, and each write method and observable calls a notification method in each observer. Okay, so now our write methods don't just do writes; they also notify observers. Okay, so our setters, our add elements, our increment counter methods become a little bit more complex. Okay, and whenever a notification method is called in the observable, saying, "Hey, I just changed," what does it do? It goes and reads from the model and says, "Oh, what's your value?" And the notification method can actually pass the value also. We'll see many variations there. Okay? And again, I'll just finish this off very quickly. So each student is registered with professor's listserv, and whenever web page is updated, imagine sending mail to students, and they say, "Oh, the web page is updated," and then they go and read the web page. Okay? This is the registration method in the model that's called by the view. So whenever a view comes up, it has to say, "I exist. Hey, model, please put me in your list." And the model says, "Okay, I just changed something. Everybody in the list, I've changed." And then every one of them goes to the web page and sees what was changed. Okay? That's the basic architecture, and what we'll do next time is look at real code to show it working. Okay? Okay, let's start. Questions? So the exam is next Tuesday, and if you haven't done so, please read my Piazza post, and I have some information about the exam there. It'll include everything till MVC. And any questions? Any other questions? Question on any other topic? Okay, let's then do the material required for your next assignment, which will not be due next week, but the week afterwards. We were looking at the model view controller pattern, and we saw that when we have an interactive application, it makes sense to separate the computation, the semantics, the model from the rest of the application. Okay? And the idea is that the same semantics could have multiple user interfaces. That's something we see often. Okay? User interfaces keep changing, whereas the underlying application, the semantics doesn't change often. Okay? And that was, we saw much before that, the whole idea of separation of concerns. And the idea is that if two things can change independently, then they should be in different classes. Okay? So the user interface can change independently from the model, so it should be in a different class. And we saw that even within a user interface, it makes sense to go and separate the component that processes input from the one that performs output. Okay? Because you could have one input be used for multiple outputs. We saw that in our example last time, and vice versa also. Okay? So you want to invoke a method, you can either use a key shortcut, you can use a menu, you can use a button, and they don't have to know about each other. They're all independent ways of changing the input. So there's no reason why they should be bound to a particular output, okay, which could use all three kinds of inputs. Okay? So that was the basic idea. And when we do this kind of separation, not only do we get logical separation, but we also get physical separation. We can put the controller on one computer, the model on one computer, the view on another computer. And so our model could be somewhere on the server, our view could be on a big screen, and our controllers, we could have multiple controllers, one for each user on their mobile phone. Okay? So this kind of architecture really makes sense when we have distribution and collaboration in general. Okay? And we saw that in general a model has write methods and read methods. And the controller invokes write methods, the view invokes read methods, and in the case of the counter, our write method was the add method. We were adding to the counter, and our read method was the get value method that was just returning the value of the counter. Okay, so that's the whole. So now we can even define what a controller or what input really means. Input really means taking user input and translating that into invocations of write methods in the model. Okay, so whatever task is needed to go and translate user input into write methods is controller tasks. And whatever tasks are needed to take the model state and display it on the screen by calling read methods on the model, that's the view. Okay? And then the question became, if the controller, view, and model are all separate, they need some coordination. Okay? So, of course, when input is given by a user, a controller will call the write method, and a view is able to call the read methods on the model to display the state. So the question became, how does the view know to go and call read methods, and it should call those read methods whenever the model changes. The model may change on its own. Okay, it may just keep incrementing the counter on its own, using some timer, for instance, or it could change it in response to a controller action. Okay, so the controller just tells the model. Controller could tell the view in certain restricted cases, situations, but in general, the controller tells the model, and the model tells all its views about it. Okay, that's where we left off last time, I believe. Okay, so I guess this is where we left off, actually. So for the model to go and inform its views, if the model informs some other object about what's happening in its state, the other object could be a view, it could be some other kind of object, then the notifying object is called the observable, and the notified objects are called the observers. Okay, and the English word is pretty self-explanatory here. And so each observer is registered with observable. Okay, that's a pattern now. We saw model view controller was a large pattern. Within it is a sub-pattern, which is the observer pattern. And each write method in the observable will call a notification method in the observer. And the notification method in the observer then reads the model. Okay, so you tell, and I gave the analogy here that each student is registered with the professor's listserv. When the web page is updated, mail is sent to students. And the mail may contain some information that's sufficient for the students to know what happened. Okay, but in general, in response to the mail, they might go to a web page to see the full information. Okay, So that's the basic real-life paradigm on which this particular idea is based. Okay? And in general, we can have multiple observers, often observable. Okay? We have multiple views displaying the same object. Or we can have an observer observing multiple observables. Okay? So if I'm teaching here, I'm trying to read your faces, lots of your faces. So each one of you is an observable, and I'm the observer. And we saw that there were actually applications that could make use of this. Okay? In fact, in your project, the object editor observes all of your models and displays it in a single view. Okay? So our model view controller paradigm now becomes a little bit more complicated. So far we had the controller invoking write methods on the model and the view invoking read methods on the model, and that's the only arrows we had. And those are the only two kinds of methods. Now we're going to have in the view a notification method. Okay, so not only does the view call methods in the model calls methods in the view also. Okay, and these are just notification methods saying I've changed. And this is how I might have changed. Okay. And for it to call notification methods in the view, there must have been a registration method in the model that the view can call to say, hey, I'm interested in becoming your observer. Okay. So we have a little bit more elaborate scheme now. Okay. And also the controller has to know about the model, and we saw last time that these things have to be all put together, and it could be, the model view controller paradigm leaves these decisions up to you. It doesn't decree how does the controller get to know the model? Well, the controller may be born with the model in a constructor argument. Some main program may go and connect them together. Similarly, there's a question of how the observers and observables get connected to each other. Did the observer actually know about the model and call the registration method, or did somebody else call the method? Okay? So when you guys enrolled in this course, automatically you became subscribers to Sakai. Okay? Some registration office connected us all together so that anything I put on Sakai, you get to see about it. Okay? Or I could go and tell you, please go enroll in Piazza. Okay? So in that case, you, as the observers, went and actually called the registration method. So these things are left undefined, and there are many ways to do it. Okay? But somehow this connection has to be. So in general, some connection method has to be called in the controller that goes and connects it to the model, and similarly the registration methods in the model have to be called. Okay, this is just saying in text what I said earlier. So let's just go and look at our code, the counter example, and see all this stuff in detail. So we had the counter before. Now we're going to have an observable counter, which is just like the counter. It has the add method and get value method. But now it has an add observer method that takes as an argument a counter observer, okay, and a remove observer method that allows also somebody to say, okay, I'm done with observing you and I don't need any more notifications. Okay. So this kind of stuff, when I've taught 110, I've taught actually at the 110 level also. It's not so hard. And many of my grad students who've taught 110 have also used these notes. And in 110 we don't do inheritance. So I haven't made observable counter an extension of counter. But if we know inheritance, that's what we would do. We would make observable counter an extension of counter. Okay. Now, when you guys do your projects, I don't recommend you go and actually create new classes and interfaces that extend previous classes and interfaces. That's a little too much. Just go and change the classes. Okay. So any class that was not observing now not an observable, make it observable by keeping the same name and just adding some more code. Okay. There's no reason to have the other class around. And it just makes things, you'll be free to do it. Okay, I won't say there's no reason, but the fruits you get are high-hanging, not low-hanging. You learned the basic concept of inheritance, and you can just, you don't need in this project to have both incarnations of your classes and interfaces. Okay, so that's kind of what I've done here. I've just changed the original class interface, and I've renamed it. Okay, so any questions about this? Okay, so all the arrows I draw, the main ideas were in the pictures I showed you. This code is just solidifying them. Okay, and your observer could be a console view, could be a J-option view, and they all implement this interface. Okay, and there's a little subtle point here because the console view and the J-option view are quite different views. You might think of them, but they implement the same interface. Okay, so it's not like a BMI spreadsheet, another BMI spreadsheet, and a Cartesian point and a polar point, which from the outside look the same. Inside they do things differently. Now we have two things that are quite different, implementing the same interface, and that happens a lot also. Okay, that their complete behavior is not described by the interfaces, and they may have more than one interface to describe their real behavior. Okay, and counter observer now has an update method that takes the observable counter as an argument, so that it can know if the counter is observing multiple models, it can know which model has actually changed, and so appropriate the appropriate part of the update the appropriate part of its display. Okay, so that's how we designed it. Those are the interfaces. So this is called whenever the model is updated, and this is the updated model. Okay, if there's only one model around, that model could have been passed as a constructor argument. Okay, so you won't need this, but just in case there's more than one model. Okay, and this is my class. And notice now how things have changed. My add method is not just adding, it's doing notification also. And the notification method, so how do you do notification? Okay, there's not going to be just one observer. There can be many observers. There can be an unbounded number of observers. So we're going to store it in some dynamic collection. Okay, and in our case, the dynamic collection is this observer list that I'm not showing you the code for. It could be an array list if you want it to be. And so anytime an observer is registered, we go and add to that list that observer. Okay, that makes sense, right? And whenever you have to notify the observers, you go through each element in the list, and you call the update method on each element, passing yourself as an argument, saying I changed. Okay, and you go and iterate through it. Okay, so that's a basic idea. Now let's go and see here. My add method did the addition, plus it did notify all observers. That makes sense, right? Whenever you add to the counter, you want to tell everybody else, I've got a new value. So some of my methods have to do this now. My get value method, it did not do any notification. So we changed some methods and not others. And what's the criteria for determining which method should change and which method shouldn't change when you make a class observable? So in general, I can divide my methods into what kinds of methods? We talked about this earlier. In a bean, you divide the methods into setters and getters. And in general, the setters are examples of write methods. And the others are examples of read methods. So which method should notify? The write methods. They change the state. Can you imagine read methods notifying also in some useful applications? Not in case of model view, perhaps. The whole idea is saying, look, I got invoked. Okay. So suppose in Facebook, if you go and change something, others can see what happened, right? So you can imagine observing. But when others go and read your stuff, you don't get to know about it. But you could imagine some criteria, some schemes where when somebody reads also, others get notified about it. Okay, so if I go to a page and I start reading it, and you go to a page and start reading at the same time, maybe you're reading the assignment, suddenly you get to know about each other and you can have a collaborative session saying, I really don't understand this part, I don't understand that part. Okay, so there might be situations where even the read method should notify, but in the model view controller scheme, that's not what happens because we're showing something visually. And visually, it's not going to change if somebody Just read the value. Okay. Now, why do you think I went and did this? That in the add observer method, I not only added the observer to the list, but I also said observer.update this. So I have a new observer. I added the observer to a list, and then I went and invoked the update method on that observer. Yeah.
The update method needs to take the observable counter, and the observable counter you want to give it is this class itself.
This instance itself. And you're telling it about it because
You change something in the model.
you change something in the model, or you haven't changed, right? The changes occur in the add method. So here you're doing the add observer. So the model, this object is now going to become your observer. So the idea is that, Zach?
You can have multiple observers.
Yeah.
Because observers
Is a list.
is a list.
And you can add observers gradually. So, like in Piazza, one person can join, activities can occur, then another person can join.
So the update makes sure you're all on the same page.
You're all on the same page. So basically, I've just become an observer, and I'm saying, hey, so the idea is that the view has only one method to go and display the model. The method is called every time the model changes, or the first time the view got to know about the model. Either way, it just redraws the whole model in our case. Okay, so it's saying, okay, draw yourself with my state. Okay, that's basically what's going on. Okay, so each write method notifies everybody. Here we are going and giving the observable the initial value, not the changes, but the initial value so that it can update. Is that? And we see here my counter console view just has one method update for initial and subsequent values. And what it does is says, here is the counter value. So when it first becomes an observer, its update puts that value in, and subsequently every time an add method is called, it goes in, displays that. Okay? G-option view, it has an update method that is just very similar, except it just makes a different API call and displays things in a dialog box, message dialog. Okay? And that's my observable part. We also have this controller, which is a separate object. And the controller has a method and again, this is not fundamental to MVC. This is how I coded this particular controller. In fact, the controller methods are not standard. Okay? The controllers call methods in the model, and everything is model-centric. So the question is, what obligations does the model have? Okay, the model has the obligation to go and notify the view. So the view interface becomes important. The model never calls a method in the controller, so the controller could have any set of methods. And in this case, the controller has a method informing it about the model so that it can forward its call input methods in it. And then it has a method that just processes input in a loop. So here's my process input method. This is just like the method we saw earlier, except that there is no output. No count. The counter is not in here. The output is not in here. And all it does is say, whenever the next input is not 0, counter.add next input. Okay. So that's my process controller loop. And questions about this? Okay. And somehow these have all got to be put together. And this is the class that's doing that. It's saying create a new observable counter. So the view, it creates a new view, and it adds the view as an observer of that model. Okay? So it's doing the connection. This is like the university connecting us all through Sakai. Okay? Then it creates a new counter controller. And in this case, I'm just being a little different to show you how things can be. I don't pass the argument as a constructor argument. I just say controller.set model, this model. So the controller could be interacting with one model at one time, another model another time, so I've got a setter method there. Okay? And after I've done all this stuff, I say controller.process input. That's a loop that keeps going on, so it better be the last statement in this main method. Otherwise, we won't even get to the rest of this code. Okay? And it all works together. Okay? And way back, I showed you code that was doing everything in one main method, And people said, maybe, we want to separate this into multiple classes so we understand things better. And, maybe I've confused things now, okay? When it was all in one method, it was very clear what was happening. Now you've got to know much more to understand what's going on. Each unit is very, very, very easy. But like I said, that putting them all together is a challenge. So you have to know that whenever the controller goes and calls a write method in the model will go and update the view, and the view will go and read the values. So everything is done more indirectly. And indirection is a very powerful concept in computer science, just to give you more flexibility. Okay. And if I want a different main, where I can compose things differently, so I can compose things in that way, or I can go and change my view from console view to J-option view, and I've got another composition. Okay, so this is the flexibility we get. That I'm not all bound together. I'm not all in one program that is totally different from any other program that uses the same kind of semantics. Those programs use the same counter, same controller. All they did was change the view. So there's a lot of sharing. That's what you get. Okay, this is the only line that changed. And there's shared input code and shared model code also. Okay, and if I want to have two views, I could do that. So I created an observable counter as before, I created a controller as before, but now I'm adding to the model two observers and two views, both of which display the model. So this is the power of composition. Okay? Questions?
I just had a question. Are you going to be talking about, do you have any Java swing on test?
Am I going to have Java?
Java swing, like, for instance, you do J-option thing. Like, are you going to have any of that going to be on test?
Oh, so the question is, should you memorize that API call or not?
Yeah, or actually all of Java.
What do you guys think? Okay. It's very interesting. I actually went to a teaching conference in Raleigh 2 years ago, and I was listening to some talks, and there was a person from CMU who was trying to prove a point that, there was a system. I told you about Alice, and they said, should Alice people learn Java also or not, and whatever. They were doing some tests, and ultimately they said, look, the students scored much better using my new philosophy rather than the old philosophy. And then I, went into the details of how exactly, what's the test. And in their exams, they check for Java syntax. Okay? So if you didn't get the syntax right, you lose points. And they proved that using her approach, they made fewer syntactical mistakes than using the previous approach. Okay? And if you've seen the exams I gave last time, I think I point out that you will not be penalized for syntactic issues. Okay? Now, if you write something that's totally not understandable, you will lose points. But if you miss a semicolon, I miss semicolons all the time, so I can't catch you guys for missing semicolons. So I will try not to ask you questions on details. Okay? But there are some details that should be in your DNA by now. And, maybe those I'll ask. And that will be a fairer question. So I'll try to be fair, and I don't think it's very fair to ask you a question on J-option pane. I don't remember those arguments. You can always look them up. But the fact that there's a J-option pane that can display things on the screen, maybe that's interesting, but that's not something that really I've gone into, right? It's just to show model view controller, which is the subject. Okay? So it's the more conceptual questions. Okay? Questions? And by the way, this topic is not on the exam. Not that you should tune off right now. But since you have not been tested in a project, in an assignment on this material, I want to only test you on stuff that on concepts that have been exercised in recitations and in assignments both. This is something for the second midterm. Okay. Other things? Okay, so we've understood the basic model view controller paradigm. Let's see some variations of it now. Okay, that's what we'll see now in the next few classes, in fact. Okay, we'll see several practical applications of this basic idea. And notice something that happened. If you're concerned about efficiency, that's an issue. So what did the model do? The model called an update method in the view and saying, I changed. It did not say how I changed. Okay? And what the update did was, go call back a method in the model. Okay, so the model sends a message, if you will, to the view saying, I've changed, and the view then goes back to the model and says, what's your current value? Okay, so, I said that this kind of stuff is useful for distributed computing. So if your observer is in USA and observer is in China, you send one message to go and say, I changed, and then another message got sent to you saying, how have you changed? And you send back a value. So a lot of traffic went, and there was a lot of latency. Okay? So the way I've described the model view controller, it works. You can keep the views up to date, but maybe it's not very efficient. So how could I go and change this particular, and I already hinted to you how that might happen. How could I make things more efficient?
You could send the change when it's changed. You can send the change with the notification.
I send the change with a notification. Okay? So I don't have my update method taking only one argument. I have an update method taking some extra argument saying what the change was, describing the change. Okay? So essentially, update must make a long distance call to read method. So I can go and say update new counter value. Okay? And now I just go and say print line. I just did some PowerPoint editing here. I might have some mistakes here. But I would say counter and new counter value, and I don't have to go and make a callback. Okay? Callback means that you call back the person who called you. Okay. And this is within the model view controller paradigm. In fact, the first paper that was written on this proposed both kinds of update methods. One in which just the updated object is sent as an argument, and in another one in which some other object is sent as an argument that describes how things changed. Okay, now supposing I wanted to display the counter observer using object editor. Okay, so the object editor, it has the counter observer. I want to display the observable, not the observer. The observer will be the object editor. So I wanted to display the observable in an object editor window. Okay, could object editor register itself as an observer of counter so that you don't have to do this annoying refresh? You just simply go and the counter, the object editor just says, it adds itself to the observer list. And whenever the add method is called, the update method is called in the object editor, and it goes and displays the new value. That would be nice. No need for this refresh method. And no need for passing refresh into your models in an awkward way. That's all messy. And whenever you guys call refresh, there's a little warning given in object editor saying, this is not really nice, but you don't know better, so it's okay. Okay? So could object editor become an observer of counter? And it would be nice, Zach.
I mean, right now only observable counter, or anyway, a specific interface is needed. So you have to change that. I think it like object editor, like an observer interface that would allow the method called update to refresh.
Okay, very good, very well stated. Okay, so counter observer is my interface, our interface. It's bound to this counter object. It's bound to the fact that there's an add method, which object editor doesn't know. Object editor doesn't know about counters. It knows about beans. Okay? Or it knows about general objects. So this counter observer is something we created, and we could have created it with this kind of update method or another kind of update method. Nothing standard here. So object editor is this very generic tool, and for the generic tool to become an observer, we need a generic observer interface. And so let's try to derive that kind of interface. It would be nice to have such an interface so that we don't have to do this refresh. So where I'm calling it counter observer, I might call it now what? Bean observer, object observer, or just observer, generic observer. Where I have an update, we can still call it update. Okay, that's a nice method. That's independent of counter. Where I have int new counter value, I would pass what, you think? So it could be int, it could be double, it could be who knows what. So what's the unifying type for all of them? object. Okay, so this could become object. And observable counter, what should go here? Object. Sorry?
Like you should create observable class.
Okay. So why can't it be object?
Because you can't observe anything else.
You can't observe every object because you need to be able to call the method addObserver in it. addObserver is not part of the class object. So we'd have to have a separate object class that has an addObserver method that takes this particular observer interface type as an argument. Okay. So can object editor become a view of counter? So no need to call refresh. Object editor does not know about counter observer and cannot implement. So, and with such interfaces and classes exist actually in Java. I'm just motivating them. So there is a class called observable that you can subclass. Okay, they should have really created an interface. They didn't. Okay, and that means that that if you want to inherit from somebody else, then you can't become an observable. You have to inherit from observable, and it has many methods. I'm just showing you two of them right now, and those also I'm not showing you completely. It has an addObserver method that takes an observer as an argument. Observer is an interface that has an update method, and it takes observable as an argument and some argument that is of type object that describes the change. Okay, so exactly what we were deriving in the previous slide, we get through Java. These are standard things, and you can use them in fact. And in fact, if you do it this way, object editor will indeed become your observer. Okay, so this will work. Questions? Okay.